All right, so the only difference with the equations we've been doing and these equations is that these equations have fractions. Okay, and we did see a couple of them like this yesterday, just more of them today. So we're still going to use inverse operations to get the variable by itself. We're just going to be doing those operations with fractions instead of with integers. All right, so we start just like always. We circle the variable. We want to get that r by itself. We draw our line of equality. Remind ourselves that whatever we do on one side, we have to do on the other. And to get this r by itself, what do we have to get rid of? We have to get rid of the 5/9, right? And how are we going to get rid of that 5/9? We're going to add it. So since that's a minus 5/9, we're going to add 5/9 to get rid of it. So a minus 5/9 and a plus 5/9, those are going to cancel each other out, right? Okay, but since I added 5/9 on the left side, I have to add it on the right side. Now I think this one's pretty easy. On the left side, those 5/9 cancel each other out completely, and that leaves us with what? R. On the right side, we have 1/9 plus 5/9, and we get 6/9. We don't have to worry about getting a common denominator because we already have one, right? All right, and are we done? Put a box around it? Why not? Yes, we can reduce this. All right, so what number goes into 6 that also goes into 9? 3. So we're going to reduce by 3. We do 6 divided by 3 and get 2. And 9 divided by 3 gives us 3. Just to clean this up, what I'm going to do is I'm going to rewrite the answer down here because remember, we always want the answer to be in the form the variable equals something. So in this case, r equals something. So I'm going to just rewrite it. R equals 2/3. And I probably didn't need to write the equals 2/3 up here. That'll save me a little writing if I just get rid of that. So this would be a good way to do that problem. So we get r equals 6/9 and then reduce it and we get r equals 2/3. Next one here we have s over 15/21 equals 28/25. This looks like a fun one, doesn't it? So I need to get that s by itself, so I'm going to get rid of what? The 15/21. Since this is s divided by 15/21, remember a fraction means division, right? So since it's s divided by 15/21, how do I get rid of it? Multiply. So we're going to multiply by 15/21, and that'll get rid of those fractions on the left side. And what do I need to do? What's that? Same thing on the right. So multiply by 15/21 on the right side also. Okay? So on the left side, those fractions are going to cancel each other out, which leaves what? S all by itself. On the right side, should we do 28 times 15? No, I don't like that because then we're going to get a big number and we're going to have to reduce. So what can we do to save ourselves from working with those big numbers? Reduce first, right? Does the 28 reduce with anything in the bottom? The 21. What goes into 28 that also goes into 21? 7. All right, so 28 divided by 7 is 4, and 21 divided by 7 is 3. All right. How about the 15? Does that reduce with anything? The 25. What goes into 25 that also goes into 15? 5. 15 divided by 5 is 3. 25 divided by 5 is 5. Okay. Is that it? I see something else. Should be a pretty easy one. Somebody said it. The 3/3, right? So we have a 3 here and a 3 here. Anytime you get the same number on the top and the bottom, you know you can reduce it. Because that number goes into it. So we divide by 3. What's 3 divided by 3? 1. And what's 3 divided by 3? 1. Anything else? No. All we have left is the 4 and the 5, right? Because the ones we know are never going to be able to reduce. So let's go ahead and multiply across now. We multiply 4 times 1 and get 4. We multiply the bottom 5 times 1 and get 5. Can I reduce 4/5? No. So we get s equals 4/5. So in the next one, we want to get y by itself. And don't forget to draw your line of equality. What are we going to do to get y by itself? Subtract 2/5. So we want to get the y by itself. We need to get rid of the 2/5 over here with it. So we subtract 2/5. And we subtract 2/5. So on the left side, those 2/5 are going to cancel each other out, and that leaves y all by itself. On the right side, we're going to have to do a little work here. Why are we going to need to do a little work? Yeah, we have different denominators. We have a 4 in one of them and a 5 in the other. Now, yesterday when we did a problem like this, I went down to the bottom and I just did some work off to the side. Let's do this another way. Since we have them stacked up, it actually works out kind of nicely here. First of all, what's our common denominator going to be? 20. So what I'm going to do is just off to the side of each of these fractions, I'm going to rewrite the fractions. So instead of 3/4, I'm going to have something over 20, and instead of 2/5, I'm going to have something over 20. What do I multiply by 4 right here to get 20? 5. So I multiply by 5 on top and get 15. Okay, and then on the bottom, what do I multiply by 5 to get 20? 4. So I multiply by 4 on top. 2 times 4 is 8. So instead of 3/4 minus 2/5, now I'm going to do 15/20 minus 8/20. And I'm just going to scratch these out here because I don't need those anymore. All right, so what is 15 over 20 minus 8 over 20? 7 over 20. All right, can I reduce that? No, can't reduce it, so we are done. All right, this last one's my favorite one. So we want to get z by itself. And so we're going to have to do the opposite of multiplication, which is division. What are we going to divide by? 4/5. So we want to get rid of the 4/5 here that's being multiplied by z. So we are going to divide by 4/5. All right, so we divide by 4/5 on both sides. This one we really do need to go off to the side and do a little work because we're not ever going to divide fractions, but we're going to change division problems into multiplication problems. All right, so on the right side, those 4/5 cancel. That leaves the z. But on the left side, we're going to have to figure out what 14 over 15 divided by 4 over 5 is. All right, so what's the acronym that we remember for division? KFC. So what does a K stand for? Keep. What are we going to keep the same? 14 over, okay. What does the F stand for? Flip. And what are we going to flip? The 4 over 5 becomes 5 over 4. And then we're going to change division to multiplication. I already threw that in there. Okay, so this is the problem that we're trying to evaluate now. And we want to, well, that's going to be our answer for z. So what do I do first? Should I multiply across? 14 times 5 is 70. 15 times 4 is 60. And no, what would be an easier way to do that? Let's reduce. Okay, what can the 14 reduce with?
7.
There's no 7 up there. What can the 14 reduce with?
2.
The 4. Okay, the 14 and the 4 reduce. What goes into 14 that also goes into 4? 2. So 14 divided by 2 is 7. 4 divided by 2 is 2. Okay, can the 7 reduce with anything else in the bottom? 15 or 2? No. How about the 5? 5 with the 15, right? So 5 and 15 reduced by 5. What's 5 divided by 5? 1. What's 15 divided by 5? 3. Okay, is there anything else that can reduce? We have a 7 and a 1 on top and a 3 and a 2 on the bottom. Can anything reduce there? No. So what do we do next? Now we multiply across. So on top we have 7 times 1 and we get 7. On the bottom we get 3 times 2, which is 6. And that's our answer. What's wrong with just boxing it right here though? Yeah, we need to put it up in the equation. So our answer is 7 over 6. We're going to write that up here. So we get 7 over 6 equals z.